So hi everyone, and welcome to today's problem. Today we want to compute the volume between these two surfaces, and these two surfaces are paraboloids along the z-axis. Okay, let's see if we can understand first these two paraboloids. A way for understanding these two paraboloids is doing a cut, okay, a vertical cut with a z-x plane. Okay. We'll do a cut with a z-x plane, which means in fact that y is equal to 0. If we do this, it's just setting y equals to 0, and what we get is that the first paraboloid is this one, and the second one is this one. If that's 20, then the first paraboloid has this shape. The second paraboloid, when x is equal to 0, z is equal to minus 1, and it goes up. Okay. We don't know if they cross here, or they cross here, up, or maybe they cross down. So that's something we should investigate. Okay. But the idea for computing the volume is as follows. So we have two paraboloids. Okay, they intersect here, and then we'll compute first this volume that is bounded by this plane and this paraboloid, and then we will compute the second volume that is bounded by this paraboloid and the same plane. Okay, so a good way for representing paraboloids that are along the z-axis is using cylindrical coordinates. These cylindrical coordinates are represented as follows. Okay, so the coordinates are rho, theta, and z. And why are these so useful? Because what we know is that x squared plus y squared is equal to rho squared. So, in our case, the first paraboloid is 20 minus rho squared, and the second paraboloid is z is equal to rho squared minus 1. Okay, now if we're interested in finding when they intersect, is when this is, so we have the same z, rho, but z's are the same, so they intersect when 20 minus rho squared is equal to rho squared minus 1. So 20 minus 1, so 21 is equal to 2 times rho squared. So rho is, solutions to this equation are square root of 21 over 2. But because we're interested in intersection, we are now interested in the negative square. So it's rho is equal to square root of 21 divided by 2. Very good. So intersection is when rho is equal to square root of 21 over 2, and the theta is in between 0 and 2 pi, and z is 1, 20 minus 21 over 2 square, which is equal to 20 minus 21 over 2 is 90 half. Okay, so they intersect here, so in fact that picture that we have here is this one. Okay, so intersect above the XE plane. Very good. Now, okay, so we have two paraboloids. That's where they intersect. then we will compute the first volume and the second volume. Volume 1, okay, the region is theta is in between 0 and 2 pi. Z is in between this tip to the plane, to 19 halves. And the tip is what? The tip is minus 1. Minus 1, Z to 19 halves. And Z and rho, because we have Z is equal to rho squared minus 1, so rho squared is equal to Z plus 1, so rho, okay, the boundary is when rho is square root of Z plus 1. So rho is in between 0 and square root of Z plus 1. Good. The region for volume 2 is theta is again in between 0 and 2 pi. Z now is in between 19 halves and recall that Z was 20 minus rho squared. So when rho is equal to 0, we get 20. Now rho is square root of 20 minus Z. So rho is in between 0 and square root of 20 minus Z. Now, because we're using cylindrical coordinates, the Jacobian is equal to rho. Jacobian is equal to rho. Because recall that cylindrical coordinates in fact is just polar coordinates times the z-axis. So in fact it's polar coordinates. Very good. So this means that the total volume, that is equal to the first volume plus the second volume, is, so the first volume is the triple integral between 0 and 2 pi. Now z was in between minus 1 and 19 halves. Rho is in between 0 and square root of z plus 1 of 1 times the Jacobian. And then this is d rho d z d theta. And the second volume is triple integral from 0 to 2 pi. From 19 halves, 19/20 or 19 halves? 19 halves to 20. Um, 0 to square root of 20 minus z, the same, rho dz d theta. So let's compute both integrals. We start by b1. We integrate, what we do is integrate rho here. So we get 0 to pi minus 1 19 halves, then we get rho squared divided by 2 from 0 to square root of z plus 1 dz d theta. This is 0 to pi minus 1 19 halves, then we substitute and we get z plus 1 over 2 minus 0. Now the integral of z plus 1 halves is what? Z squared over 4 plus z halves, then this is in between minus 1 and 19 halves d theta. Now we substitute from 0 to 2 pi, and this is what? 19 halves squared over 4 plus 19 h, no, 19 fourths minus a fourth plus a half. And all this theta. Because this is a number, what we get is 2 pi times all this number. That can be computed. Be my guest, you will enjoy it. How much is this? Okay? Second volume is done similarly. Okay? So we must first integrate this. So we get rho squared divided by 2, and so on. So we get rho squared divided by 2 in between 0 square root of 20 minus z dz d theta. So we get 0 to pi, 19 halves, 20, and then we substitute 20 minus z over 2 dz d theta. We integrate again, 0 to pi, 19 halves, sorry, now we integrate. To integrate this, so this is 10z minus z squared divided by 4, this in between 19 halves and 20 d theta. So what we get is 0 to pi. Now what we get? 200 minus 404 minus this plus d theta, and now again, so because this is constant, the integral of all this with respect to theta is this. Good. So we got volume 2. We got volume 1. So total volume is the sum of all these. We factorize by 2 pi, and what we get is this plus 19 fourths plus a fourth and by the way, this is a 4. This is a 4. Plus 200 minus 100 minus 190 divided by 2 plus 19 squared. Very good. Be my guest and simplify this. It's up to you.